When we talk about monitoring and controlling an electrical network, we are talking about systems that accurately measure currents and voltages at different points in the network. These measuring systems have a necessary component called a measuring transformer. A measuring transformer is an electrical device used to measure currents or voltages in a circuit without interrupting the main flow. Its primary function is to provide signals to measuring instruments or control devices without affecting the operation of the main circuit. Transformers electromagnetically reproduce an alternating current or voltage, which helps reduce heat dissipation problems and strong magnetic fields that can disturb measuring instruments, as well as isolating the operator from the rest of the system for safety. They are also called protection transformers when they help to manage the power and current flow on a network. Alternatively, when they have to carry measurement signals to instruments such as ammeters and voltmeters, they can be called reducers, precisely because they reduce the signal strength to facilitate reading. These devices are installed in switchboards of industrial plants where continuous monitoring of the energy flow is required, allowing the optimal operation of the entire plant. Let's see how they're designed on the inside. The measuring transformer consists of a magnetic core and two windings, a primary and a secondary. The main current to be measured is passed through the primary winding, or the voltage to be measured is applied to the ends of the primary winding, while the secondary winding is connected to a measuring device, such as an ammeter or a voltmeter. The family of measurement transformers is divided into two macro categories: amperometric transformers, or CTs, and voltametric transformers, or VTs. A current reducer, or CT, is a transformer capable of supplying its output terminals with a current of a value congruent with the available measuring instruments and capable of faithfully representing the input current. Current reducers are mainly used in the measurement of high currents, which exceed the capacities of the measuring instruments, and in the measurement of currents on high voltage networks in order to isolate the reading circuit and the operator. Current transformers are typically used to reduce the line current to a standardized secondary value of 5 amps or 1 amp. They are basically inductive sensors consisting of a primary winding, a magnetic core, and a secondary winding. Essentially, a high current is transformed into a lower one using a magnetic circuit, so very high currents can be measured safely and efficiently. In most CTs, the primary winding has very few turns, while the secondary winding has many more turns. This coil ratio between the primary and secondary winding determines how much the current load is reduced. The current transformer is a simple component of the system, but plays a very important role because the accuracy of the measurement depends on it. Indeed, it must be taken into account that the CT's own uncertainty must be added to that of the instrument to determine the total accuracy of the measurement. As the saying goes, the strength of a chain is limited to its weakest link. Therefore, it becomes clear that in order to achieve the desired accuracies, it is not enough to choose quality instruments alone, but also equally essential to combine it with a current transformer with a suitable accuracy class and sufficient power. Now, let's take a look at voltmetric transformers. A voltage reducer, or VT, is a transformer capable of supplying its output terminals with a voltage of a value congruent with the available measuring instruments, and such that it faithfully represents the input voltage. The voltage at the secondary is reduced in amplitude by a known amount with fixed accuracy and is in phase with the primary voltage with fixed accuracy. The voltage reducer is connected in shunt to a line whose voltage needs to be measured and has a voltmeter at the secondary. Inside, there are two windings, the primary and secondary. The characteristic feature of the VT is that it has more turns in the primary winding than the secondary winding. As with the CT, the energy source is connected to the primary terminals. The energy flow passes through the primary winding, and via magnetic circuit passes to the secondary winding, and then to the output terminals. VTs always function as voltage reducers, and their secondary load is one or more voltmeter circuits of measuring instruments, such as voltmeters and wattmeters, which normally operate at low voltage, typically 100 volts. The VT is characterized by an apparent power that must never be exceeded. To avoid damage, it is equipped with protection fuses connected in series to the primary circuit, which have the task of limiting the maximum current that can circulate within it. JAES, in cooperation with Watson, provides the best solutions for measuring and monitoring power lines for industrial plants. With the great experience of both companies, they are able to provide accurate guidance in selecting the right product, and then customizing it according to the customer's specific requirements in order to optimize the productivity and efficiency of the plant. If you found this video useful, let us know by leaving a like and a comment. You can also share it, and don't forget to subscribe to our channel. We recommend you visit our website, jaescompany.com, to find out about our upcoming projects.